Here then is, here are two exam questions requiring that candidates know or at least understand how to use trigonometry. So in the first one we've got this character Ali who uses trigonometry very basic trigonometry to estimate rather, the height of a flagpole. And in the second one, well, we've got this triangle here, so it's a very abstract question. You're given 31-degree angle, you're given this length here of 16 centimeters, and you need to find the height h. Let's tackle this functional question first then. So this is testing the functional skills of people. Are they able to use trigonometry in sort of everyday situations? So the examiner's remarks said that this was the most challenging of the functional maths question, the questions that they set on that paper, with the majority of candidates having no idea what to do. Only 2% of candidates scored both marks. A further 8% calculated the height of the flagpole, but they couldn't provide a valid mathematical reason why the angle of 45 degrees was used, and this apparently was required for the full 2 marks. 18% of the candidates just didn't make any attempt at answering this question. So it really was something that people found quite puzzling, and they didn't know how to approach it. So let's see if we can clear up a few ideas here. Okay, so the first thing is to read the question carefully. So Ali uses this method to estimate the height of the flagpole. Let's go through it carefully then. He stands as shown. Okay, so he just stands vertically like this, so that his angle of sight is 45 degrees when he looks up to the top of the flagpole. So that's the first thing he does. He stands here so that he's got a 45-degree angle. Well, he must have used something like a theodolite to get exactly a 45-degree angle here. But however he did it, he chose to do it, and later on in the question they'll ask us why he chose to do this. Alright, so that's the first bit, and nothing much to worry us there. Second bit, he then measures his distance from the flagpole, and in fact they've given us the measurement here. So his distance from the flagpole is 8.7 meters. In that case, the side of this triangle must be 8.7 meters, so I'll just write it on the diagram here. Let's just write 8.7, so we know it's in meters. Keep it nice and simple. So we've now got this 45-degree angle, and we've got 8.7 meter distance. Okay? Thirdly, he measures the distance that his eyes are above the ground. Okay, it's also given us that distance here, so it's 1.45. So I don't think I need to rewrite that. That's simply the distance here. And in fact, that gives us part of the flagpole. Let's say it gives us F1. Let's just label it F1. So F1 equals 1.45. Okay, so what have we got to do? The sketch shows us Ali's measurements. They aren't drawn accurately, so we can't use it to measure ratios and so on. It just gives us an idea. What we have to do is use Ali's measurements to calculate the height of the flagpole, explaining why he uses an angle of 45 degrees. Well, in that case, it's clear that what we need to do is find F2. Okay, we know F1, but if we call this F2, that's what we need to find. Then we add F1 and F2 and we'll get the height of the flagpole, which is the answer. Hopefully along the way we'll also explain why he uses an angle of 45 degrees. But let's just start by calculating it out. Now, if we've got a 45-degree triangle, this should remind us of our trigonometric special triangles. We've got the 30, 60, 90 triangle, but in this case we've got the 45, 45, 90 triangle. Okay, let's just highlight one of those angles, this one here, but they're both 45. Now we can fill in our ratios then, because we know that in a 45, 45, 90 triangle we have 1 to 1 to root 2 ratios. Okay, and we can use those to help us answer the question. They help us, for example, without even reaching for our calculator, to know what the tan of 45 degrees is. And the tan of 45 degrees, which is the opposite over the adjacent, is exactly what we want to find. We don't want the sine, because that would be the opposite over the hypotenuse, and we don't know the length of this diagonal here. Nor do we want the cosine, because that would also be using the hypotenuse. And so it's nothing to do with the hypotenuse, it must be the tangent, because it's the opposite over the adjacent. And the tangent of both of these angles is just 1 divided by 1, in other words 1. So we can say now, we can set up a little equation, we can say now that f2, which we want to find, f2, which is the opposite, over 8.7, which is the adjacent, well, that will give us a value of 1, because the tan of 45 degree, which is the opposite over adjacent, equals 1. So what's f2? Well, if we multiply both sides by 8.7, then this will be removed from the denominator and it will appear on the other side. So if we multiply the left-hand side by 8.7, we'll have just f2, because 8.7 divided by 8.7 is 1. On the right-hand side, 1 times 8.7, so we do the same to the right as we do to the left. 1 times 8.7 is just 8.7. So f2 must equal 8.7 meters. Now that's curious, because we did discover, or we were given, that the side here was 8.7 as well. So what have we got? An isosceles triangle. And of course we should have realized that, because we've got a 1 to 1 to root 2. These sides are equal. So the reason why Ali used this 45 degree angle must be that Ali, that's right, chose 45 degrees, 45 degree triangle, because it is isosceles. Isosceles. Therefore, height equals, let's call it 8.7. Let's just write 8.7. Height equals the length, the distance, if you like. We could put height equals distance. Let's just write that. Therefore, there we go. Height equals distance. And that should satisfy the examiners. We've explained why he used an angle of 45 degrees, so that height equals distance, so that he didn't actually need to use the tangent function. He simply needed to say, well, if I'm 45 degrees away, then f2 must equal 8.7, the same distance as I'm standing away from the building. Okay, now we understand that. What's remaining is simply to find the height of the flagpole. Well, the height of the flagpole is, what is it? It's f1 plus f2. So f1 plus f2 is, well, f1 we've already worked out is 1.45 and f2 is 8.7. Now those are horrible numbers, and although if I've got a calculator I could quickly pop those in, it'd be much nicer to tidy them up. So I'm just going to write equals, I want that to be 9 because it's not far away from 9. So if I add 0.3 to that, then I must subtract 0.3 from that. That'll just make my numbers much nicer. My 1.45 minus 0.3 is going to give me 1.15, and 8.7 add my 0.3 gives me just 9. Therefore my answer is, okay, equals 10.15 meters. So quite a lot of problem solving to do there, quite a lot of thinking about what you need to do. Working it through step by step, though, should get you nice and safely the right answer. Okay, let's work on problem 2. Now, let's have a look at the examiner's remarks. Very brief. They say simply that this question was generally poorly understood, with many students, I'm afraid, using incorrect trigonometrical ratios, or even mixing up angles and lengths. So they even saw, for example, this thing, 31 times tan 16. So a lot of confusion here, and I guess we just need to go through this carefully to see how it works. Now, once again, what I'm going to do is think about my special triangles. We've already talked about the 1, 1, root 2, or the 45, 45, 90 triangle. Here we've got something close to the 30, 60, 90 triangle. And if you remember that one, it would have its sides in the ratio of, well, the shortest side is going to be 1, the longest side is the hypotenuse, which is 2. Okay, and then we have this root 3 length here. Now, the only problem with this is if we were going to, for example, use the opposite over the adjacent again, because that's what we seem to have here. So h is opposite the angle, and 16 is, there we go, the adjacent side. So we're using tangent again. Normally, if it was 30 degrees, we could say, well, we know without reaching for the calculator that the tangent of 30 degrees is 1 divided by root 3, or 1 over root 3. So let's write that down. Tan of 30 degrees equals 1 over root 3. But in fact that won't help us here, because we don't want the tan of 30 degrees, we want the tan of 31 degrees. So the tan of 31 degrees is not something that we're going to be able to do without a table of values or a calculator. So, assuming they allow us to use a calculator, I do hope so, then we've got the tan of 31. Well, my calculator tells me that the tan of 31 is 0.60086, and on it goes. That's good enough, I think, for the moment. I'm going to keep it in my calculator, because what I want to do next is set up an equation that I'm going to use. Let's use the space down here. So we've got all the information now. We've done our little bit of planning and thinking. Time to answer the question. So what have I got? I know that the tan of 31 degrees equals that. I know that the tan of 31 degrees, the tangent is going to be the height over 16. So I know therefore that h divided by 16 must equal 0.60086 ... On it goes. What do I do next? Well, if I multiply both sides of this equation by 16, then I'm just going to get h on its own, because 16 times h over 16 cancels the 16s to just give me h, and this times 16 I write as 16 times 0.60086. So I'm glad I kept it in my calculator. I now press the times button and 16. There we go. And I get the value 9.613769, and I'll go ... There are more digits on my calculator, but I really don't need them, because the answer I've got to give is in centimeters, and it's not going to be useful to, I wouldn't have thought, to go into beyond 1/10 of a millimeter. So I think I'm going to give my answer as 9.61 centimeters. So that's 9 centimetres and 6.1 millimetres. The only thing to remember here is that I really should put an exact value, and if I don't put an exact value, I need to say it's only approximately equal to this value. Okay, so if I write a new line, actually it'll be easier. So therefore h is approximately equal to 9.61. And what have I done? I've rounded to 2 decimal places. So in brackets here, I'm going to put 2 dp, so the examiner knows that I realize that this isn't an exact value. Okay,